Good morning, all. As Vivek has already introduced, I am Bhakti, and today I am going to take you through NLP Advanced Bird Score presentation. So, let me share my screen. Just a minute. Hope the screen is visible now.
Yes, it is visible.
Okay. So, once again, welcome all. And today I'm going to take you all through the BERT score, that is evaluating text generation with BERT. So this is today's contents. Basically, our objective is to go through the bird score and understanding of it. However, today we might be having the audience who which is from various experience. So I just wanted to start with the little basics and then go to the bird score. So that is why we all are seeing here confusion matrix recap, and then TF-IDF, transformer, BERT family, then prior matrices of BERT score, and then understanding BERT score, advantages of BERT score, conclusion, reference, and summary. And finally, we will going and running the BERT score in Python. At the end of the session, all of us will be aware of bird score. Will understand the bird score and topics around the bird score. As I said, everyone in the audience will should understand. That is the reason topics around the bird score also have. I'm going to discuss here. Then implementation of bird score in Python. So let's see recap. So a recap of this confusion matrix that all of us are aware, this precision, recall, and F1. Quickly, we will just touch base. So precision is nothing but false positive, and it is very important where the false positive is of the higher concern, and these are used for import music or video recommendation system, e-commerce website, etc. And the formula for it is true positive divided by true positive plus false positive. Then recall is nothing but a false negative, and this matrix is used whenever false negative is of the higher concern. For example, the healthcare domain where actual positive case should not go the undetected. This is a formula for recall, that is TP divided by TP, that is true positive divided by true positive plus false negative. And then F1 is the harmonic mean of these both and give us the idea of these two matrices together. Next, going to the TF-IDF, it is a term frequency inverse document frequency. So this gives us the importance of particular word in other words, like that is important, a rare word in entire corpus. So its range is between 0 to 1. So 1 being higher, so those who are having the TF-IDF score as 1, those are the rare words and worth seeing into entire corpus. So on the right hand side, you can see the formula for calculation of TF and then calculation of IDF. Then let's come to the transformer. So in year 2017, Google Machine Translation has published a paper of attention is all you need, wherein the first time the transformer architecture was released. And then in 2018, BERT has been released, which is evolution over the transformer. The name itself of the BERT is bidirectional encoder representations from transformers. Then let us have a quick look at the transformer architecture. So as a name suggested, attention is all you need. So transformer architecture is using attention mechanism. So this helps us to give contextual information of every word. And as I said, it is a architecture. As LSTM shares the architecture, similarly, transformer is a architecture. So on the right hand side, you can see this is a attention mechanism, and this decoder encoding position and encoder decoder mechanism. The advantages of transformer architecture over RNN, CNN, and LSTM are, so with respect to RNN, they are parallel functioning architecture. So it trains bigger models in parallelizing mode, whereas RNN are the sequential, and transformers are much faster than RNN. Compared to CNN, transformers are robust, and then compared to LSTM, that is long short-term memory architecture, it is LSTM is harder, whereas it is transformer is easier, and the transfer learning can happen correctively in the transformer, which is not possible with the LSTM architectures. Then coming to the BERT family, so these are the different models. So we can see Elmo, UML Fit, and GPT. Now, Elmo and UML Fit, they use the LSTM architecture, whereas GPT uses transformer architecture, and BERT uses the evaluation of transformer architecture. And then we can see these are the various models or various architecture of the BERT. This is various variation of the BERT. So for the different data sets, different problem statement, and different hyperparameters, this variety of BERT models are being used. Next, pre-trained model. So if we go back, these all are the pre-trained models. So what is this pre-trained models are? Pre-trained model and transfer learning, they go hand in hand. So basically, pre-trained models will be having the entire knowledge, and which has been transferred to the new upcoming task or new upcoming models. So what happens is it is been rigorously trained on the large database, and it gives the qualitative output and the higher speed. So coming to the definition, transfer learning is a machine learning method where we reuse a pre-trained model as the starting point of the model on the new task. So this can be the in the real life analogy is professors comes with their degrees and their knowledge, and when they teach to the student, they transfer that learning to the student, and then from there further the student takes the knowledge and develop themselves. So this is what is the pre-trained models and the transfer learning. So what are the advantages of pre-trained models or transfer learning? They are easier to implement, higher accuracy, and require less training time. And the thing is, they already have well-trained models, so there is no need of training the entire data set. Then, uh, then coming to BERT score. So how the BERT look like? So this is the architecture of BERT. I told you, right? It is the evolution of the transformer. So it says I only need the encoder part of the network. So it is using attention mechanism and the encoder. It do not use the decoder part of the transformer. BERT is deep bidirectional supervised language representation pre-trained using plain text corpus. As a result, the pre-trained BERT model can be fine-tuned with just one additional output layer to create state-of-art models for wide range of the tasks. So here I have listed only two tasks, like a downstream task like question answering and language inference, but there are many more. So the moral of thing is, since BERT is pre-trained properly, we can use very less layers of the output and get whatever desired output. Then coming to the BERT. So to explain the BERT mechanism, there are two existing strategies for applying the pre-trained models. So what are those? Those are feature-based and fine-tuning. So Elmo is being the feature-based model, and it transfers the trained feature to the downstream task. Whereas fine tune, for example, GPT is fine tune approach, and it takes a very minimal task specific parameter, and it gives fine tunes all pre-trained parameters to the downstream task. These two approaches, motivation is same, objective is same, but they are unidirectional. So this technique restrict the power of pre-trained representation. So why so? Because they have the major limitation, that is they are unidirectional, and then because of that they limit the choice of architecture that can be used during the pre-training. So to explain more, for example, GPT, it is a unidirectional model and uses the architecture of left to right. Every token is only attained to previous tokens through the self attention layer, but it would be harmful. Where it would be harmful, like the task which are having the question answering session at that time, where the context of entire word or entire sentence would be needed from both the direction, there this model fails. Okay, so then how BERT work is the BERT weights are learned in advance through two unsupervised tasks. So what are those? MLM, mask language modeling. So what is this mask language modeling? Like language modeling is the task of predicting next word given in the sequence of word. But in the mask language modeling, instead of predicting every next token, whatever is masked, that only been asked to predict. So 80% of tokens are masked here. Now, what is the need of masking here? It's because, as we know, BERT is bidirectional model, and due to its bidirectional nature, it tend to leak the information. So instead of predicting the correct word, it will just copy whatever it knows in the previous layer. So by making a masking, we are making BERT to learn much more on the qualitative side, and then it gives the correct result at the new task, at the new models or new data sets. And then the unsupervised task next is NSP, that is next sentence prediction. So BERT also gives the next sentence prediction. What is this next sentence prediction? For example, if we have two sentence A, sentence, let's say labeled A and labeled B. So it finds out whether the sentence labeled B is the second sentence and sentence labeled A is the first sentence. And this is very much needed for a natural language inference. So example, when the question answering system is there, for example, this question answering nowadays, because of the COVID, we are all techno savvy and doing all the works in the online. So if we order anything on the Amazon, or people working in companies, they need to have any help from the HR, there is a chatbot, and then chatbot, you need to ask the question and the chatbot gives you the answer. So this question answering system really needs the specific relation between the two sentence, which is done in the BERT make use of transformer and attention mechanism that learns contextual relation between words or subwords in the text. Okay, then going to the next slide, how BERT works. So basically, when sentence comes in, BERT first do the position embedding, then segment, that is sentence embedding, and then the token embedding. So in the position embedding, what happens is it to find out the position of each and every word in the sequence or in the sentence. And this is what is the added feature in BERT over the limitation of transformer. So transformer was not able to find out the position of the word. Okay, and then the segment embeddings, that is the every segment here, the if the pair of the sentence has been given, then sentence segregating sentence A and sentence B would be done, and finding out the embedding of the sentences. So here in the figure, if you see, all labeled A are these tokens are related to sentence A, and all labeled B. These are related to sentence B. And then token embedding, if you see here, token embedding, these are the embedding learned for specific token from the word piece token vocabulary. So this word piece token vocabulary is having the entire word set given by the Google for different languages. So in the token embedding, there are special tokens CLS, which indicates start of the sentence, and SEP, that is a separated, which gives separation of the two sentence. For example, my dog is cute is separated with this SEP token from he likes play or playing. Okay. Then next, so how is this BERT is? So BERT is available in the two layers, the two types, that is BERT base and BERT large. And as I said, it uses the encoder only. So this all the mechanism, the multi-head attention, then forward period, this entire contributes to one encoder only. So like that, BERT base will be having 12 encoders and BERT large will be having 24 encoder. So let's see how information flows in the BERT model. So word starts with its embedding representation from the embedding layer. So this is the embedding layer. So this is the entry point of starting the embedding. Every layer does some multi-headed attention computation on the word representation of previous layer to create new intermediate representation. So if here, if you see, they are communicating to each and every tokens. And then in figures, in this figure, E1 is the starting point, T1 is the final token, and TRM are the intermediate representation token. If the BERT model is the 12 layer, then this intermediate representation happens 12 times. When it is 24 layer model, then it happens 24 times. Okay. Then again, we'll discuss these three models like Elmo, OpenGPT, and BERT. So Elmo uses LSTM bidirectional, but not at the every point. Not at the every point. GPT is using transformer, and it is unidirectional. But if you see, which we have already discussed, it talks to every node at every layer. So this is how the construction wise BERT is different from other models. And then OpenGPT and BERT, they are fine-tune based approach, whereas Elmo is feature based approach. Now, with knowing all this information, let's come to know that what makes BERT different. So all these things we have already discussed. So if we see the path pre-trained representation, then contextual, exactly finding out the meaning of word and the sentences. Then bidirectional, BERT is giving deep, that means every layer it communicates. So what the answer for this question is, only BERT representation are jointly conditioned on both left and right context in all the layer. And then this is needed for the chatbot, for the system like question answer system like chatbot. So every layer we need to have the context right here. So once the BERT is trained and fine-tuned, the same is given as an input layer to the other task, that is question answering or entity recognition or language inference models, next task. So since this is a pre-trained model, they will be giving this as in the input, whereas this would be the output layer. So coming to pre-train and the transfer learning, as we have as previously I told, only output layers are different. So these are the application, or these are the problem statement given at will be put at the output layer of pre-trained model, and gives exactly functioning what we want. And this slide I have put in some task where the input BERT pre-trained model is used. There are many more, but I have listed few here. Then before actually going to the BERT score, let's have a quick tour of what are the prior matrices has been used for the BERT evaluation. So why it is needed is we need to understand what are the flaws, and hence we need to see. Hello.
Yes, all good. Go ahead.
Oh, okay. I thought. So, any questions till now? Hope I am clear till here, right?
Audience, feel free to ask your questions if you have any.
Okay, then I will just go ahead. So before going to the BERT score, let us discuss the prior matrices used for evaluating the text generation. This is a quick tour, and we are not doing the deep dive on this. This is just for the awareness purpose. So these are the other evaluating metrics: n-gram matching approaches, then edit distance based, then embedded based, and learned metrics. So let's see the n-gram matching approaches. It is having BLEU, METER, and many more matrices. So BLEU is a widely used and famous matrix, and it used three modification. First is it reference to exact n each n-gram in reference can be matched at most one. Then second one is exact matches is accumulated for reference candidate pair, and third one is very short candidate are discouraged using bravery penalty. So BLEU is restricted to maximum n-gram length, whereas BERT score is not restricted to maximum n-gram length, but instead relies on contextualized embedding that are able to capture dependencies of potential unbounded length. So this is the advantage of BERT score over the n-gram matrix over BLEU. Then next is meter. So instead of unigram matching, it is directly matched the word to the word stem. For example, running will be matched as run. And those which are not matching, those which are not exact matching, it depends on external system. And because it requires the external system, there are very few language where it supports. But BERT score allows relaxed matches, but relies on BERT embedding that are trained on the large amount of raw text and available for current 104 languages. Since Meter uses external system, it is just available for few languages. However, the BERT score have available for more languages. So this is the advantage of BERT score over Meter. Then these are the few other n-gram matrices: NIST, CHRF, RUCH, CEDAR. So if you want to read more on that, I will be share. I have already shared the link in the references. I will take you through on that.
Hello.
Yeah.
I have one question at this point. So
Yes.
these particular matrices are task specific, which means they are pertinent to a given downstream task, or can be applied to any given task that we are trying to achieve using BERT.
No, these are not BERT matrices. Okay, these are the matrices of just language evaluation prior to the BERT. Okay, generally
Okay.
how we have other evaluation matrices for general data science stream. So like that, this is for the text evaluation matrices prior to the BERT they have used.
Okay. Thank you.
Yeah. So next is edit based matrices. So several methods use word edit distance or word error rate, which quantify similarity using number of edit operation required to get from candidate to reference. So this is TER, PER, CEDAR, character, and EED. So again, in the reference, I will show you where you can go for further more reading on this. So embedding based matrices, they are learned dense token representation. So Mint 2.0 and EC1, this uses greedy matching for their work for computation, whereas this WMDO, SMS, they use optimal matching best concept for their work. So here the computation is done on similarity with sentence level representation. On contrast, BERT is our token level computation allows us to weigh token differently according to their importance. Meaning here every word is been tokenized and every word is been compared in the BERT. So that is the advantage of BERT over the embedded based matrix. Then learned matrix. Various metrics are trained to optimize correlation with human judgment. These are BER, blend, and RIS. But these metrics need costly human judgment as a supervision for each data set. And they also exhibit the risk of generalizing poorly to the new database. This is why so because they need a human judgment intervention here. However, BERT score is not optimized for any specific evaluation task, and hence they give the qualitative output and maximum matches. So coming to the BERT score, so BERT score is automatic evaluation metric used for testing the goodness of text generation system. And BERT score focuses on computing semantic, that is contextual similarity between tokens of candidate sentence and the reference sentence. So this is the BERT score. So if you see in the figure, we have reference sentence X, then candidate sentence X cap. This is run through the contextual embedding, and it will create the vector of every word to the other sentences. And then from that, the maximum similarity matrix is generated, and on that we calculate recall, precision, and the F1 matrix. It also gives the importance of weighing, that is IDF, that TF-IDF is also giving. It also gives us the result. So this is in nutshell. So on the discussion of this, we will be touching on the token representation, then similarity measure, BERT score, importance of weighing, and baselines rescaling. So coming to the token representation, here the contextual embedding is used to represent the tokens in the input sentences X and X cap. So this is the reference sentence and X cap. So between these two, contextual embedding is been done. Okay, so this generate different vector presentation for the same word in different sentence depending upon the surrounding words. So this is the beauty of BERT, which was not available in the prior word embedding. So what does this mean exactly? So for example, the girl is fair, and my friend did not get a fair treatment from his boss. So these two sentences are having different context, different meaning, but the word fair has same meaning. So in this case, what happens? Every word is been vectorized with different word in the different from the reference sentence. Okay, so then the model used to generate these embedding are most commonly trained using various language modeling objectives such as mask word prediction. So when we were discussing the masking of BERT, that time I have already mentioned that it would be trained with a large data set and maximum masking, so that it for the downstream task it will definitely perform correctly up to the mark and acceptable limits. Okay, so then unknown words are split into the several common observed sequence of the characters. The representation of each word is computed with transformer encoder by repeatedly applying self-attention and non-linear transformation in alternating fashion. Like how I have explained in the previous slide, word fair. So like that, it will, through the transformer encoder, it will repeatedly do the self-attention and get the vectors to pull out the exact meaning or the exact context of the candidate sentence. Given a token as a reference sentence, so X, here X, the weather is cold today, is embedding model is generated in the sequence of vectors. So this, after embedding, the sequence of vector x to xk will get generated. And similarly for candidate sentence x cap, that it is freezing today, will get converted to x1 cap to xl cap. Okay, so vectorization happens here. Then the main model uses BERT, which tokenize the input text into a sentence of word pieces where unknown words are split into the several commonly observed sequence of the characters. So once the vectors is generated, then the unknown words are also separated, and they will be compared through the corpus to get the or the word piece library, through the word piece library, to get the exact meaning of it. Then similarity measure, after we are having vector, this similarity matrix would get generated. This is the vector representation allow for the soft measure of similarity. So this similarity matrix will get generated. The cosine similarity of reference token xi and candidate token x cap j. So the cosine similarity of x to the x cap given by the mathematical formula is dot product of reference transpose to the candidate and divided by the magnitude of these both. However, these are the we have used the pre-normalized vector. That's why this calculation is reduces just to the dot product. Then BERT score, the BERT score, like the token in x to the token in x cap gives us the recall, whereas the token in x cap to token in x gives us the precision. This uses greedy matching to maximize the matching similarity score. So this, to get the maximum similarity score, greedy matching technique has been used. So here, what is greedy matching is each token is matched to the most similar token in the other sentence. Okay, so then then it does the precision and recall computation and gives the harmonic mean f1. So this is a formula for recall. So recall is the summation of dot product of reference transpose to candidate sentence and then divided by the magnitude of the reference sentence. Whereas precision is the summation of transpose of reference to the dot product of transpose of a reference to the candidate sentence x cap over divided by the magnitude of the x cap. And this is the f-BERT, which gives us the combination of this idea of combination of p and recall. Then coming to the importance of weighing, BERT score also gives us the idea of weights. So importance of every word. So it gives us the knowledge of rare words. So as we have discussed in the recap, one where the score is 1 is the rare word and it's worth checking in the entire document. And BERT score, as I said, BERT score enable us easily incorporate importance of weighing. So with this, we get the idea of weights, and the actual formula is TF minus IDF. But since we are processing every sentence one time, that's why TF is likely to be 1. Hence the RBERT, RBERT, it would be like the mathematical expression is a dot product multiplication into the IDF multiplication. This is the summation and divided by the summation of values of IDF. Now, much better explained here is like this. So this is this formula will be explained with this number. So RBERT will be calculated maximum matching, that is 0.713 into 1.27 plus 0.515 into 7.94. Similarly, it will go for other rows and divided by the summation of this IDF, like 1.27 plus 7.94, all those things, and finally gives us 0.753. This is how the calculation, and looking at the similarity matrix, you can see the weather is cold today. What is this? This is the reference sentence, which is on y-axis, and the candidate sentence is it is freezing today. So this is on x-axis. So greedy match gives us the maximum matching. So it and they have maximum matching 0.73. Then is having maximum matching is 0.8558. These are the same word. Whereas weather, you see weather and the freezing. So basically, freezing is the information about the weather. So freezing is not the weather, but it is the attribute of the weather, or it is giving special information about the weather. So when it is matching, it is giving the number 0.515. Whereas freezing and cold, they belongs to one family. Hence their similarity score is raised compared to weather and freezing to cold and freezing. So if you see, it is 0.796. And finally, today is the same word, so 0.913. Okay, so this is what is the bird score. Then baselining. So whatever values we get, that is from the cosine similarity, and range of cosine similarity is -1 to 1. But what happens is, in doing this, it makes actual score less readable because the range of score is lesser. So here what we do is we do the baselining of all these scores. So after doing baselining, this falls in the range of 0 to 1, and it is much more readable, or maximum we can increase, we will get the maximum readability of the score. So doing so, it will not affect the ranking ability of human correlation of bird score, and it is only we are doing it for the score, increase the score readability. So this is the formula for R-BERT. So cap R-BERT is equal to R-BERT minus B upon 1 minus B. So similar way, the precision and F is calculated for the baselining. Then coming to advantages, we have already discussed the advantages with every prior matrices. But again, it is BERT is conceptually simple and empirical. BERT score is used 104 languages. It just do the BERT embedding and do not need the extra resources, but also gives us the importance of weighing, that is IDF. Then coming to the result, this table shows us the Pearson correlation with human judgment on MSR abstractive text comparison dataset. So if you see, here is the BERT score, here is the common metrics. These are the common metrics what we have discussed, and the best matrices. So these are divided into meaning, grammar, and combined. If you see, the most acceptable score gives by BERT score only compared to other these matrices. Okay. Next, coming to the BERT score visualization. So this figure shows cosine similarity is in color coded. And when I was talking about the embedded word embedding of the word, like it gives the positioning of every word. So here it would be explained more. Like if you see, BERT score will find out synonyms correctly. For example, imported and foreign, they have it has recognized properly. Then the disorder or highly distortion in the orders of the word also it can find correctly. For example, people and people. So if you see, people here at the first and people here at the last, but still it has found out correctly. Okay, so this is the BERT score visualization. Then coming to the conclusion, BERT score is a new metric for evaluating generated text against gold standard references. BERT score is purposely designed to be simple, task agnostic, and easy to use. BERT score revolves some of the limitation of commonly used matrices. Then BERT score achieves better correlation than common matrices and is effective for model selection. However, no one BERT configuration is clearly outperforms to all others. For example, whatever BERT family we have seen, we cannot comment that a particular BERT model will work for all downstreaming tasks. For example, variation of the BERT score, which I have shown it here. So let me go back and explain this point. So these are the variation of the bird. So so none of this we can say that for example our bird will perform very well in on all the downstreaming tasks. So this is not the case. So that's why initially I said they work for they are designed for different databases, different problem statement, and different hyperparameters. Okay, I hope this point is clear now. So going back to the conclusion again. So then example here is if the text generation in English, the recommendation is 24 layer robot large model to be used for calculating the bird score. Whereas for non-English languages, bird multi is suitable for calculating bird score. Okay, and then for machine translation evaluation, if bird found to be most reliable metrics. So this is the table which gives us number of layers and best layer for the BERT model. So selecting good model or good combination of layer from the BERT model is very, very important. If you see, this is BERT based multilingual case is 12 layer and best layer is 9. So this is what is the shown in the table. So then coming to the summary, we have done the recap of precision, recall, F1 score, TF-IDF. Then we have seen transformer architecture in short, then BERT family and architecture. Then what are the metrics we used before BERT? We understood the BERT score and visualization of BERT score. And further deep dive, if anyone wants to do, I'll be sharing the references in the next slide. And then we'll go through the Python lab to know the BERT score. So these are few references. And then now we'll go to the lab. So the code is available on the GitHub at this this URL. So I'll just take you through to the code and then program. So this is a GitHub where the code lies. So let me start. This is a Cellstart hub. Let me see if it is working. Otherwise, I need to restart it. Okay, so I really have to restart this. So this is Cellstart hub. It will take some few minutes.
Audience, any questions or comments meanwhile? Some comments came on chat. So any other comments? So the maths was quite well explained, I thought, with the, the F1 score and the recall and precision.
Okay.
So are folks new to BERT and transformer, or we know that from before?
So till it get processed, let me go to the GitHub and show you the code here. So basically, this is the BERT score. This is this link I have given. I'll just reopen this.
So what is BERT in one line? Bhakti, what is BERT?
But if I can say, it is the evolution of a transformer architecture, and it's a very simple technique, simple architecture helps us. It's a bidirectional. It's a bidirectional. If we say it is, in the single word. Bidirectional encoder representation from transformer. This is the one liner we can say about it.
So transformers are the new things compared to RNN for language processing.
Yes.
Until few years back, RNN LSTM was state of the art for language processing.
Yes.
Recurrent neural network and LSTM RNN. Later on, transformers from Hugging Face became state of the art, and BERT from Google DeepMind is based on transformers.
Yes. So let me start the Jupyter notebook here. Okay. Coming back to the code, so this is where on the GitHub the code lies. So this is a BERT score. This is what was the today's topic we were discussing about, and it do have this score py. So this file will import from the BERT score and do the calculation and find out the BERT score on that. So,
there is a question on chat. Apart from BERT score, what are the other metrics to evaluate BERT-based models?
So BERT-based model, I only know this BERT score. I need to see, but as per my knowledge, BERT score only the best. There are no other models, metrics to check on that.
So BLEU is another one. So BLEU can be used. You were showing BLEU before, BLEU, right? So, but it is not BERT based, right? It's
It is, yeah, it is before BERT. What are the matrices used for the text generation? That's what we have discussed. So BLEU doesn't come for the BERT-based models.
right.
So I'll open this code and let's go one by one. So
You can increase the font or the screen size slightly.
okay, now is it visible?
Yes, it is visible. It is visible.
Okay. So what we are doing here is installing the torch and the transformer. So BERT is using both of them. So that's why we are installing that. Then we will be installing the BERT score. Okay. So this BERT score is nothing but just now I have shown the this one. And through that we will be importing the score py. So once the BERT score is installed, we are importing the score from the BERT score. Okay. So then we need to clone this GitHub because we are using couple of files from them. So I have already cloned it. That's why I have just commented. Otherwise, after cloning, we will get same structure. If you see this same structure, we will get in the CellStat hub. So see, this is BERT score. So if I open, you will see the BERT score, then examples here, all the code will get downloaded here. Okay. So after cloning, then I am assigning this candidate sentence. So this candidate will use this hypes.txt. So in this BERT score, which is very well on the GitHub. So in the example, see, this is the file. Okay. So this is the file for candidates. Then this is a file for reference. So I'm assigning this file to cants and a reference. So after assigning, if we can see, okay, I'll rerun this. Then if we can see the first line where in the cants, so it is HYPS. So we can see this one. Okay. Then we are calculating PR and F1 score. Let me run this. So this is PR and F1 is there. In the score pivot. See, this is how it is. So this is the code. One minute, let me show you. Calculations. Max predict. So this is a code for baselining also. See this one. The formula, mathematical formula I have shown for the baselining, it is calculating it here. Let's go back and see whether it has done. So this is F1 is done. Now I'll run this. I'll get the F1 score here. And this is the mean of F1. Then let us see how this F1 is distributed over the beans. So if I run this, I will get the distribution of the F score over this in the 20 beans. Okay, then let us see the similarity matrix of it. So if I run this, I will get the similarity matrix of it. This before, see this one. So if you see the candidate sentence, 28-year-old chef found dead in San Francisco Mall. So similarly, 28-year-old chef found dead at San Francisco Mall. So for every word, we get the similarity. See, as I explained in the session, the same similar way, it gives the dark blue point where the maximum similarity comes up. Okay, so this is what is the finding out the BERT score. So again, this is a GitHub, and here the code lies. After cloning, we get it in our local, and here are the files which gives us the score and the example details. Okay, so one more, like what exactly we have seen in the discussion. Let me try running that and show it to you. So till it get run. So that's it. After discussing this result, I have done for today's presentation. If any questions, please let me know.
There are some questions in chat.
Okay, I will just check that. 1 minute. The sentence what we discuss is the weather is cold today and it is freezing today. So the similarity matrix shows like that. So it gives the maximum similarity. If you see the and it, they are into the same stop word family. Weather weather is as I discussed, it is not that, then is, then cold and freezing mostly match, and today is match. So this is what is a total discussion of the bird score. Let me go and check the chats now. Mm. Okay, Sanat, is this open source? Meaning GitHub is accessible to everyone, so you can go to that path and download the code as a cloning of the GitHub I have shown. Like that, you can do it. Then how can the result of bird-based model using bird score can be compared with matrices that are not non-bird based? It is apple to apple comparison. I am referring the slide where result was shown. Okay, Kurunga, let me go to that slide. So non bird based. So today's topic is bird based comparison only. It's not non based. Okay, so this bird score is applicable only for the bird based matrices. Okay, next is Sindhu. Okay, thank you so much, Sindhu. So oh, this is question for Vivek, but before that, uh, uh, Kumar, what is the, how do we spell you? Kushagra.
Kushagra.
It is Kushagra, actually.
Am I clear on your question?
Actually, I'm not able to understand this aspect of the bird score. When you shown a result where blue and other matrices were mentioned, they were evaluated based on non-bird based model, and their results were published, like F1
Yes.
score and other scores.
Yeah.
Now, bird score is the only score, as you mentioned, or maybe is the only score that is currently scoring, or is the only metric that is currently scoring the bird-based model.
Yes.
So how can two different kind of matrices, which are made for two different kinds of architecture or two different kinds of model, one being the predecessor, the other being the of next generation, can be compared, and we can overall conclude in a scientific way or in a research point of view that this particular is better than this. So
Okay.
unless and until we have a metric that applies to both kind of apply to the same kind of architecture or same kind for this PERT is one example, and then we can say that okay, this matrix applies, these two matrices apply on the same architecture, but see, this is a better in terms of explainability or in terms of on any other parameter.
So Bhakti, go back to that slide you had where you're doing comparison.
Yes, yes.
I have the answer to that question, but you can try first.
Yeah, yeah.
Yeah, you just put it in presentation mode, I guess.
Yeah, yeah. Just a minute. I'm just going to the slide and then.
Yeah, you can put it in presentation mode.
So as per my understanding, Kushagra, so this bird score, since the architecture entire thing is different, so it is going to the every word level compared to other techniques. Okay, and a bird, as you know, since it is bidirectional, it do not miss any meaning or any context of the word or the sentence. So hence, it is proving correctly here. However, other matrices, now whatever techniques has been used, they are not given the exact context of the word and the exact contents of the sentence. That's the reason the meaning using the old thing, if you see, the figures are not acceptable, whereas in the bird score the figures are acceptable.
So yeah, let me augment that Bhakti here. So bird score is using bird doesn't mean that it cannot be used for any other language situations. It's a generic language metric model, and it can be used in all circumstances, regardless of whether those circumstances were BERT related or not. Okay, so BERT score itself uses BERT. Doesn't mean it will only be used for measuring metrics only for BERT models. And on the inverse side, Blue Score, Meteor, Rogue, L can be used for non-BERT and BERT-based models as well. So these are generic, all of them are generic matrices. All of them can be used for all situations. It's just that BERT score itself is a BERT-based phenomenon. I hope that answers Kushagra.
Yeah. Thanks for that clarification, because I had because the name is it sounds like it is so pertinent to BERT, because the name itself is BERT score. So I thought it can't be applied to other kind of.
No, it is actually a application of BERT. BERT score is one more use case of BERT language model. So, it is a scoring technique which is based on BERT tokens, BERT embeddings, but it can be applied to other textual situations. The
Okay, I
input
have
problem
another
could be
question.
generic text problems. Yes, it need not be BERT related models only.
Okay, I have another question. How a BERT score would look like or can be interpreted when we have a task like Q&A or like question answering task for named entity entity recognition in those kind of NLP tasks. How would BERT score look like interpretability on that?
I mean, in all cases, you will have a candidate and predicted sentence, right? Wherever there is a candidate sentence and a predicted sentence, BERT score can play a role essentially. So in question answer, you would have the expected situation and the predicted situation, right? So wherever there is a X and Y available, BERT score will play a role. Question answer, NER also you have an X and Y available, right?
Yeah. Thank you.
Sentence completion task, sentence fill in the blank task, sentence similarity task. Wherever there is a candidate sentence and a reference sentence situation, BERT score can play a role. Bhakti, correct me if I'm wrong.
Yes. And basically, you know what, that pre-trained model will have this as the downstream task. So it is having its own data, like questions and paragraph, like the chatbot, what we do for HR or Amazon and all that. It do have its paragraph and questions. Okay. So with this input information, it gives the output, and on that the BERT score is calculated. Similarly for entity recognition, similarly for inference of the national NLP.
Thank you, Bhakti. Thank you, Vivek, for answering the question.
Let me go. Okay. Any other question? So Kushagra means I'm about to give there's references. So see, if you want to go more detail of it, these are the three papers. Okay, this attention is for the transformer, what we discussed. Then this is for the BERT model, BERT evolution, and this is the paper for BERT score evaluation text generation with BERT. So if you want to do much more, still more deep dive, you can refer these papers, and whatever references I have given here, you can go through that. This one, this is basically a transformer paper. This is BERT and this is BERT score paper, and there are different reference links here. and here. So those who want to go for a NLP basic, I have given the link for my previous webinar also. So these are the references. So Kushagra, please do visit all these things and get back to me if you have any questions again. So that's it from my side.
Okay, thanks, Bhakti. Audience, any further questions?
Yeah, Vivek, 1 minute. Sindhu has one question. Ma'am, you will provide certificate for this workshop. This question is for Vivek. Vivek, can you clarify that?
Just for attending, we don't give any certificate. I'm sorry. So if we have certification courses and internships, so all of you are welcome to enroll in our courses and certificates program and internship program. So Bhakti is also a student candidate with us, and also now a product intern, and now an AI research scientist, as you can see. So we are able to train folks, and they become advanced AI researchers. So a very nice session, Bhakti, very well explained and detailed research. Thank you very much.
Yeah, thank you so much. Thank you, Mr. Janak, for your valuable comments. Thank you, Sanat. Thank you, everyone on the webinar. Thank you so much.
Thank you all for joining. Thanks, Bhakti. See you next time.